Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring applications of the Pythagorean Theorem. The Pythagorean Theorem is one of the most used ideas in all of mathematics because of how often right triangles arise in real-world situations. Let's start off with an example. An isosceles triangle, which means that two of the sides are equal. In this case, we have one side that's 10 inches, and on the other side it's also 10 inches. So I'm going to put a slash in there to show that they're congruent. The legs both have a length of 10 inches, and the base has a length of 12 inches. We want to find the area of the triangle. Now, the area formula for a triangle is area equals 1/2 base times height. Now, we know the base of this triangle is 12. Unfortunately, we do not know the height of the triangle. So we're going to be using, in this problem, the Pythagorean Theorem to help us find the solution. So in part A, it says draw a line from the vertex perpendicular to the base and draw in the right angle. So let's do that real quick. So I'm going to draw in a line which would represent the height of this triangle. Now, if we draw a perpendicular line from the vertex all the way down to the base, we know that this will form a right triangle. So let me put a little symbol for right triangle here. So this is our right triangle. It also told us to label this line segment with an H, and the H in this case stands for the height of the triangle. Now, in part B, it says draw a right triangle below that represents half of this isosceles triangle. So in other words, they're wanting us to draw a model just for this part of the isosceles triangle, so half of it. So I'm going to do that right here. I'll draw in just half of this model. Now, in this model, it says to label the dimensions and H. So we know this was our height. We know this was 10. And then if we just want half of the base, we're just looking at this area right here. And so that would have to be 6, okay? So that's the model we're going to use to find the value of H. Oh, and I forgot to draw in the right triangle. That's really important because you can only use Pythagorean Theorem if you have a right angle. And in this case, we do. So I'm going to label these three sides. This be my short side, I'll label it A. My other leg, I'll label B. And my hypotenuse, I'll label C. So I know that 6 squared plus H squared must equal 10 squared. Now I want to get the H squared by itself, so I'll subtract 6 squared from both sides. So H squared will equal 10 squared minus 6 squared. Now, if you'd like to, you can use a calculator to calculate that. So 10 squared minus 6 squared is going to be 64. Now, if I know H squared is 64 and I want to know H, then I'll just need to take the square root of both sides. So that means we have a height of 8 inches. So I'm going to come back over here and label the height of my isosceles triangle to be 8. All right. Now that we know the height of the triangle, we can use our area formula. Area equals 1/2 times the base times the height to find the area. So 1/2 of 12 times the height, which is 8. So 1/2 of 12 is 6. 6 times 8 is, so 48 square inches. All right, example 2. A trapezoid is shown below. Find the perimeter of the trapezoid. So to find the perimeter of anything, we add all the sides. So we have 3 of the sides given, but we do not know this side. So we're going to have to use a little bit of creativity to find the length of this side. And luckily for us, we can use the Pythagorean Theorem if we do kind of like we did in example 1, we draw in the height of this trapezoid. So if I were to draw in a segment for the height, it would form a right angle with the base. And I actually know the height now of this trapezoid. It is 12 inches. Okay. Now I can also find this small segment here. Let's see. I can find the length of this segment right here because I know the entire segment is 15 and I know my small base was 10. So if I subtract those, I know that this little segment here is 5 centimeters. All right. So we can use the Pythagorean theorem again because we have a right triangle. So let me draw a model of what we're trying to solve here. We have a triangle that has a long leg of 12, a short leg of 5, and a hypotenuse right here. We want to know the length of the hypotenuse. So we know that 5 squared plus 12 squared has to equal c squared. So let's put that in our calculator. 5 squared plus 12 squared is 169 is equal to c squared. And then take the square root of both sides. And the square root of 169 is 13. So now I know the length of this diagonal is 13, which means this is 13. Now, to get the perimeter, I simply add up all 4 sides. So the perimeter would be 10 plus 13 plus 15 plus 12. So 10 plus 13 plus 15 plus 12. So 50 centimeters. All right, example 3. A farmer wants to put a fence around a triangular shaped garden with the dimensions shown. If the fence will cost $14.99 per foot, how much will it cost the farmer to buy the fencing for his garden? So what's going to happen here is he wants to put a fence all the way around his garden. And for each foot, it's going to cost $14.99. So when you're dealing with fence problems, you're almost always dealing with perimeter. So remember, to find perimeter, we need to add up all 3 sides of this garden. But I only know 2 sides. Well, lucky for us, we have a right triangle in this problem. So we can say that 6 squared plus 8 squared equals c squared. So 6 squared plus 8 squared is 100. And then take the square root of both sides. So we know our hypotenuse is 10 feet. So now we can going to get our perimeter by adding up all 3 sides. And that would be what, 24 feet? And we know that each foot is $14.99. So to find the cost, we would take $14.99 and multiply that by 24 feet. So $14.99 times 24. $359.76. $359.76. All right, example 4. The Johnson Middle School has a baseball field that is shaped like a square. with each side of the square measuring 90 feet. If the baseball was thrown from home plate to second base and then from second base to third base, how many feet did the baseball travel? Round to the nearest tenth. Now, just a reminder, just in case you don't know how a baseball diamond works, your home plate is here and you have first base, second base, and third base. Okay, so what's happening here is that the baseball is traveling from home plate to second base, so that would be like this, and then from second base to third base, so that would be like this. So we want to know the distance it would travel. Now I'm going to draw in this third side. So remember, they told us that each side of the baseball diamond is 90 feet. So I'm going to put a 90 there and there. In order to know the distance traveled, we would also need to know this length. Now, luckily, we form a right angle here, so we can find that by using our Pythagorean theorem. So 90 squared plus 90 squared equals c squared. So 90 squared plus 90 squared is 16,200. Then take the square root of both sides. So square root of 16,200. And that gives us 127.3. So our diagonal is approximately 127.3 feet. So let me label that. All right. Now, let's go back and make sure we answered the question. If the baseball was thrown from home plate to second base, and then from second to third, how long did the baseball travel? So what we need to do is add up 127.3 plus 90. 127.3 plus 90. So 217.3. All right, example 5. To travel to her friend's house, Ashley normally walks 63 yards north and then 16 yards west. Now, to answer this question, let me just remind you what a compass looks like. If you start here and you travel north, that means you're going up. So this is north, this would be south. And then on a compass, this would be west, this would be east. All right. So draw a diagram to represent this problem and then determine the distance in yards that Ashley walks to her friend's house. So let's say Ashley started right here, okay? And she traveled 63 yards north. That would look like this, up, straight up, okay? And I'll label that 63. Now it says she walks 16 yards to the west. I want a shorter segment going to the left or west, and we will label that with the 16 yards. And they want to know, determine the distance in yards that Ashley walked to her friend's house. So her distance would equal 63 plus 16, which that would be what? 79 yards total. So she walked 79 yards, okay? In part B, it says, how many yards shorter would it be if Ashley took the diagonal shortcut? So let me draw in. What if Ashley started here, but instead of going north and then west, what if she went diagonally straight to her friend's house like that? What would that distance be? All right. So we can use the Pythagorean theorem here, and we can say 16 squared plus 63 squared is equal to c squared. So let's put that in the calculator. 16 squared plus 63 squared is 4225. And then take the square root, 4225. So C is equal to 65 yards. So I know that the shortcut is equal to 65 yards. Now, look carefully at the question. The question did not say what is the distance of the shortcut. The question said how many yards shorter would it be if she took the shortcut. So what we have to do is take her original distance, 79, and subtract the shortcut. So that would be 14 yards. So she would save 14 yards by taking the shortcut. And that concludes today's lesson, Applications of Pythagorean Theorem.